Alright, we back. Let me just get this started up. I might just do this from my comfy chair right here. Hold on, let me just shift over. The black screen. Yeah, I haven't. Alright, and we're gonna put some music on. Hold on, actually, while I get this set up. Alright, get some tunes. And we are set. Let's go. Why is that? Oh, there we go. Like, why is that black? Alright, so this was yesterday's shader, Disorientation. So this was actually a 2D one I just felt like doing for a while. It's a bunch of separate rotating vortices, so they end up like rotating around each other. It's really just don't like. I swear to God, if you stare at that, try and follow one of the points, and then stare away, and everything swirls around it. I actually didn't mean for that to happen. I swear, it just happened. So I don't know what I'm gonna. This one's gonna be kind of about like micro facets or micro materials, micro material materialization. I don't know. So this one's going to start out as just a pretty simple ray marked one. I don't think I'm going to do ray marking though. I actually think I'm going to do voxel ray tracing for this. So that way, because this scene is basically going to be voxels when it comes down to it, I think that would be fastest. So hold on, let me I've actually been meaning to look back at this voxel ray tracing code, because I didn't understand completely how it worked, but I think I have a better idea of it now. God, I'm just gonna have to sign in. I wish there was a way to search like your own. Oh my god, Shader Toy has followers now? When did this happen? Oh no, the death of Shader Toy. Okay, screw it. You know what? This is just gonna come up if I search up Voxel Builder. I'm calling it. Yeah, the only one. So this is an in-browser. This is a voxel editor. All in browser. On Shader Toy. All of the code for the editor is in shader code. So if you see up the top right here, you can You can select the color, you can place it with space. It's really hard to use because of course there's no real UI or anything because it's a shader, but it is a voxel editor, and then you can render it out in path traced version. Boom. So let's look at the voxel ray tracing color. This is what I'm interested in. So this is actually something I have the need to remake as a little WebGL app, a voxel editor with an actual web app. So it's way easier to edit, much nicer. Okay. These bounces. Oh, trace. Okay, so distance is the distance to the current edge of a voxel. This uses the vector instructions to calculate which is the current closest face. Adds that current closest face for the distance to move to that. Yeah. Yep. So we're just... I think I might actually rewrite this just to practice. So first of all, let's write our scene. I'm just thinking here, do I need normals? I think I do need normals. Yeah. I'm gonna stop this while I'm not doing anything with it. You know what? Let's start out with a mostly blank shader for this. Alright, so the camera's just pointed forward 10 units back. I'm just thinking how I want to do this. You know, I'm just gonna jump straight into it. I think I'm going to, I'm just looking at this. It needs to recalculate, these values when it traces again. So it can't do like ray marking where you do one big loop. You need to have these separate trace functions. And I want to have multiple bounces in this. Anyways, I guess we'll make it as a trace function. So this returns the vec4 position of the voxel. Yeah, we're gonna need to basically rewrite this trace function. Like I said, I want to do that anyways to practice, so... Take in the ray position, ray direction. Explore that to the voxel space. Is that signed? No. wonder why it doesn't reallocate mask each time here. I think that was just me writing crappy code before. So what should the view distance be? So this is the interesting thing about this as well. This is going to be, so the idea for this map is it's going to be a flat plane with different columns going across of the materials, and the materials are just going to be different different patterns of voxels. And so first of all, it's going to show a completely flat plane, how that makes a mirror. It's going to be a single material, just a mirror BRDF, where it just perfectly reflects rays. And then it's going to, basically the shader's going to show is how if you have all these tiny little materials like voxels, from a faraway distance, they average out to look like a roughness, even when it's the rays bouncing perfectly. It's just bouncing off these tiny materials. So that's what I'm going to try to show, is micro facets. So that's why I think the voxel Alright. See how that looks. Oh yeah, and this isn't going to do any path tracing at the beginning. This is just going to be like a perfect mirror. But this is the core of path tracing right here. Bouncing array around in different paths. Collecting the color of the materials. The materials here are just having a constant color of 0.95 for now. I think we are going to color the different bands though that I want to do. And then it's getting light from the background here, which is blue with a sunlight. So let's see how this looks. Okay. It's completely white. Oh, this is supposed to be 1 minus length. Oh. There we go. Now, why is it reflected? Oh, yeah. I'm like, why is it reflected when our scene is a flat plane? So there's the sunlight. We're going to change the curve of that a little bit. Make that look a little bit better. I think we might actually make the sunlight small like this. Or smallish, so that way the lighting is defined. Anyways, there is the beginning. So now we need to add our little details here. So that will make it really noisy, but let's begin. I wonder if I can use the hash function. So I could use this to calculate, because this outputs 4, I could use this to calculate sections of 4 at once. I'm not going to overcomplicate it, I don't think. I'm just going to make this a simple for loop. So what we're going to do now, we're going to make a grid of cubes, of random cubes. So the minimum distance is going to be the distance to the cube, or minimum distance that could be to a nearby cube, which I believe is 0.5. Let me think about this. No, it's 1. Okay. Then we do need to loop by surrounding cubes. This isn't going to be particularly efficient, but this is a visualization. Not about being some optimized real-time app. I gotta remember that sometimes, like, in terms of optimization. Max. Okay, actually, so now I probably am not going to use this hash because this would make it way slower, I think. I think I'm going to just use R4 itself right here. The H is going to be our hash. Oh, wait. I need the different... I actually need R1 for this, I think, the golden ratio. Why did I click that? I just clicked the first shader there. That's what I wanted. Oh yeah, while we're here, just to show this off again, if you want to use this shader viewer that I use to capture videos and all this and do audio visualization, it's up on my website now. Source code Damn. Move it down a little bit more so it doesn't... I actually wondered, is this move over time, and is that why it clips? I think it is. So I think it might actually need to go down it like that. Oh, I don't even have I don't have proper lighting on it. This should actually darken as it's lower down. So like this should get lighter as it goes up above the surface. So we can just feed in the position like this. Times 0.1. This will make it light up to 10 units down. Yeah, so it'll be dark down here, and then you get the effect of the mirror going up there. Oh yeah. I can actually, this will actually make a nice looping one. Oh my god, though, I actually think it's... I can actually hear my computer running way louder. Have I dropped any frames? No. Good. I thought I just saw that it drop frames for a second, but it didn't. I was just seeing things. Let's try 60 FPS again. Let's see if it lags. Oh yeah, it is lagging a little bit with 60 FPS. Can't keep 60. What about 40? Okay, it can kind of keep 40. I want to get it so it doesn't clip through the blocks as much. Oh man, I'm actually thinking of implementing this voxel, the voxel ray tracing that'll make this way faster. Since I'm not happy with not being able to hit 60. I mean, it doesn't really matter, I can still render out the frames. It's just I am going to do things like this in the future. And I guess the voxel ray tracing is going to be way better. So I think that's what I'm going to do. I am going to implement the voxel ray tracing. Oh. So this is the question though. How could I implement the voxel ray tracing as a sort of for loop like this? Yeah, you know what? Nah. I'm not going to obsess over optimization with this. Let's focus on making it look good. Let's see if we can't get it to sort of slide in between the blocks without running into them. Better. Ooh, that is really good up until it's not. Oh yeah, that's actually really good. Okay, speeding that up a little bit. So I'm going to try something, lowering the iterations here. And I wonder if there's a way I can make it to like skip the next block. Oh, interesting. So I'm almost wondering this low epsilon tracing with sort of a blur and anti-aliasing might make them look like very nice ice cubes. I may just need to work with that. I like how it goes to a soft glow out there. I might try doing a jitter and a temporal anti-aliasing. Speed up the camera movement so that I can watch where it goes. I think maybe I can offset it a little bit so that it doesn't end up right up against the blocks. You can actually see where it goes down there. Maybe I've got to go deeper. try adding some temporal anti-aliasing. Alright, so that's basic jitter for the anti-aliasing. Now we just blend frames. Unexpected floating point constant. Oh, there's no comma there. That looks nice. Now let me try something. I did something to make this have less motion blur, where I subtracted a little bit and multiplied a little bit upward. Let me try it with extreme motion blur and see how it works. Oh, I'm doing minus 0.99. That's way too much. It's supposed to be minus 0.01. There we go. Now let's turn the anti-blur up. Yeah, so I remember this. It takes away color precision. Oh yeah. Ooh. I remember what I actually ended up doing was like a random jitter based off this screen hash. Where some frames refreshed quicker than others. So then this turns into H, Z, so randomly mixes. See if it holds 60 FPS. It does. move this over. This way we can get both these on screen at once. Ooh, that's a lot better. You know what I could always do? I could actually add custom code that just clears the path for the camera, so that there's never blocks where the camera's going. Maybe not move it over, maybe just move it over 1.5. Now I'm just going to try offsetting the time until oh, that's so close. We could always just also lower the probability. Now there's less blocks. I actually think it's so much cooler when it's full of blocks, like this. Except for the fact that the camera keeps hitting them. There needs to be a way. I need to get it to somehow reflect even when it's inside the blocks there. If dot normal equals 0, then RT equals negative. Let's try that. No. We don't do a dive through the rifts, there's certain angles. Yeah, that's what I've been trying to do with sine and cosine. But as far as I'm aware, the rifts are kind of going straight down in diagonal lines. So it wouldn't be able to go back up, it would just go like straight down a hole basically. So instead I'm trying to fix these, like how I can actually make it show a lot of blocks here even while it's flying through. But these black areas of where it clips into the blocks ends up looking off. I want to get it so it doesn't clip through here. I think I'm just going to try and just step the ray forward massively. I'm not sure. There we go. Booyah. Okay, now let's slow it back down to the original speed. We can actually put it a little bit closer now. Oh yeah, that's nice. I still think I can get it clipping through less. Alright, let's try it with less and more blocks. This with really sparse, very few blocks. That still looks cool. You can see the blocks reflecting in the other blocks. Oh, what if I had to increase the probability of blocks over time? Oh, yeah. Block probability. So over a distance of 100, we're gonna have it increase the chances of blocks. Whoa. What is this? says highest probability of blocks first right here. Okay, so we actually want it to go down. We want it to go from lower probability to higher. Can your theory change the viewing angle? Oh yeah, I can change the viewing angle. This will point it backwards. I could also rotate it around so that it looks around. But I like to put it forward so it's almost looping. That's not bad going backwards either, though. Normally moving the viewing angle around and rotating it while it goes makes it like a lot harder to tell what's going on, when it's already kind of hard to tell what's going on. That should increase blocks as it goes. I feel like I should do it something like logarithmic though, so it's like you kind of see. Yeah, I don't know. It's not going to end up moving fast enough, I think, to see the blocks changing amounts. Maybe if we did PAL 2. Could actually increase it quickly so we see what's happening. Oh, there's an issue with the distance function from that though. So making that non-constant also slows things down a lot. I might spin the camera around. Whoa, why are things warping sideways? Oh, it's doing the ray position plus beforehand. There we go. Alright, so that's it with it rotating as it goes. That's kind of nice. I think I'm gonna remove the anti-aliasing. Doesn't really add much. If I was gonna do it, I think I would do proper, where I sum multiple frames. So this makes it clearer, but less smooth. That really is nice. Especially at full view distance. Oh man. Alright, I think we're ready to do our rendering of this. I'm not gonna call this one materialization today. What am I gonna call this one? I got sidetracked. Also, I'm still not sure if I like it better with less cubes. There's more reflections. That's nice. Could just call it something super simple like reflection, but maybe misdirection. That's basically reflection, and just saying it another way. Let's render videos of this. I might capture more than 10 seconds of video for this one. I really like this one. And 10 seconds of video might be too much. Or sorry, too little. You can see it slowly rendering out frames here. I feel like I should do a longer video of this because this is like nice. I don't know. I think that's good though. So I'm thinking I'm going to do a screenshot now. I'm thinking for the screenshot, I'm going to turn the epsilon up. So yeah, it looks way sharper here. Do one screenshot up here. So that, oh man, this is something I've noticed. Capturing large screenshots has been crashing the program. I don't know if that's a program with libpng or the details of this. How does this look? Not bad. I'm really curious why this all of a sudden is crashing from certain large images. I'm honestly super curious if it's a libpng bug. Yeah, so it just crashed there as well. I don't like that shot that well. Take another one. I want to get a shot where the camera is kind of like turned around. Oh, this might be a good one. So I think what happens is if I close and minimize the program before it finishes rendering out, so instead of this one, I think I'm going to do this one. Because I think it's a better shot from the sun angle. Hold on, I gotta try this though. I think part of the reason this is crashing is because I'm minimizing after capturing it. No? Okay, so it's just crashing whenever it captures. Trying to find a nice frame to capture from. I can't really render at a high frame rate though, at this high resolution. There we go, that's a nice one. So, I am... Okay, first of all, I gotta name this. I think of the name though. Well, I'm determined to figure out what's crashing this. I really think it must have been something that I added when I did the FFmpeg piping. Because it didn't crash like this until that. Okay, video frames equals 0, capturing image times 4, size of void times window height. Capture rows, capture equals true. If capture read pixels, if video frames equals 0, so whatever it's doing when it's freeing the capture pixels here, there's something about capture pixels right here that's making it. I swear it's this. I save PNG. Is exactly the same, isn't it? Like I didn't change something here. Data, dimensions, row pixels. Vertical flip, true. I could try turning off capture rows and vertical flip, but to begin, let's just try not freeing the capture pixels. Oh my god, wait. Oh, why is it doing it over and over again? Oh! What? What is happening there? Saved frame images. Oh, there's nothing setting capture to false after this. Oh, so it ended up freeing it multiple times. There we go. Boom, no crash. Okay. And also, it sometimes, rushes ahead. Do we have GL flush here or anything? Ah, whatever. Just glad I fixed that. Okay. What are we gonna name this? What are we gonna name this? This ended up being an 1.5-hour stream. Wow. I thought this was gonna be quick. I don't know to call it reflection. Like, that's way too simple. Is abstract simple or is abstract obfuscated? I don't know. I think I might just call it indirection. Let me just make sure this means what I think it does, right? Being indirect, lacking straightforwardness. deviousness. I could name it. Oh, devious would be a. Devious. Oh my god, that is a good name. We're gonna call this one devious because the ray deviates a giant amount. There we go. Well, there is March 11th shader art. Oh my god, we ended up doing this stream until 11:30. I was planning for this to be quick, but here we are. That happens though. There's a daily shader art. The wallpaper version of that and the animation will be up on my Twitter very soon. If you would like any information about the code, I'm always on Discord if you have any questions. I will see you around. I hope you have a good day. Thank you for watching. Bye-bye.